Golioth's Bluetooth to cloud capabilities are allowing even lower power devices to connect to the internet through our standard gateways up to the Golioth cloud. This is enabling a range of new applications, and we're super excited to see what our private access members are building and what they're enabling using the Golioth Bluetooth SDK. Because we build on top of Zephyr, we have a wide range of hardware that is supported in the ecosystem, and ultimately anything with a Bluetooth module on board that works in Zephyr could work on Golioth. But today we're going to show you another one of those actually working and building it up because it's supported in Zephyr, because it has Bluetooth. Now, because it works with Golioth, it's able to connect to the internet and get all of the services that Golioth offers through our Bluetooth cloud capabilities. So enjoy today as we talk to the STM32WB5MM-DK, a ST micro board that has Bluetooth on board and a bunch of other sensors, which we're also going to enable. Today we're enabling Golioth Bluetooth to cloud on some new hardware. We've already done this on Nordic and XP. Today, my good friend Mike here is going to show us how we do this on the STM32WB5MM-DK. Hey Mike, how you doing?
Yeah, I'm doing pretty good. I think I'm excited about this because I often hear people, they're like, oh, I did this and then did that and you did that. And they're like, can you just like show me how you got from point A to point B? And so we're going to be doing it with a bunch of different boards. We just grabbed this ST board as our first one to get started on the Golioth BLE private access program.
That's right. And, a lot of this is based around the fact that we build on top of Zephyr. The Golioth Bluetooth SDK is built on top of Zephyr as well for now. And that means that things that have Bluetooth compatibility within Zephyr, in theory, should work with our stuff. And we're kind of proving that out live as we go. And that, we're just going to bring people down the path with us. So if you have any questions as you're watching, we are going to be watching the chat here. You can drop some questions in. We'll try and answer them as we can. We should be broadcasting to both YouTube and LinkedIn now. And if you're watching this after the fact, you can always ask us questions over on the Golioth forum. That's forum.golioth.io. All right, Mike, where should we start?
Well, I think we should start by talking about what the Golioth BLE private access is all about.
Good question. Yeah, good point. What do you got for us, Mike?
Well, I think you're the one that's been talking about this the most, but I always think of it this way. We at Golioth support any IP-based devices, so internet protocol, and through a bunch of different stuff like cellular and Wi-Fi and Ethernet and even Thread, because that's IP-based. But what we've had a lot of requests for are Bluetooth devices, and that means using a gateway. And so we had a great team over on the engineers squad at Golioth to put together firmware for a Bluetooth gateway device that uses cellular, and then leaf nodes that connect to that Bluetooth device and thereby connect to Golioth. So your IoT fleet that's Bluetooth based, you can go and hit the internet, get data to and from it, just using one of those gateways.
Yeah, that's a good point. The only distinction I'd add is really that is based on it's made to be more generic for non-IP generally, but Bluetooth is the name of the game. That is the most requested thing that we have, like you said, the most requested thing that we do been asked for, and it's we've already seen so many cool new devices that we get to talk to and have talk back to the internet through them.
Yeah, and so we picked this STM32WB5MM-DK, which is not in focus because the camera doesn't do that apparently. Sorry, folks. But we picked it, let's see, because it has support in the Zephyr tree, but we haven't worked with it. And technically Golioth doesn't support this. Like, it's not one of our verified boards. It's not something we've connected to Golioth before. So we're gonna do that today.
Right. Yeah, I think the only way you would have been able to get that working is if you had like a secondary modem, like an ESP32AT, ESP-AT based like Wi-Fi modem attached to it or something like that. Then yes, in theory it could work, but it's not something we're regularly testing.
Yeah. So if you want to try out Bluetooth private access with Golioth, you can totally do it. There's a bunch of blog posts about it. The page that I'm on right here is GitHub Golioth, and then it's a BLE private access repository. So BLE private access right up here. And there's a link that says apply here on this form. And we'd love to help you through that process if you just want to try that out. Our end goal today, so I already have a gateway running that's running on a Nordic NRF9160DK, which has a Bluetooth chip on it as well as a cellular chip on it. So it's scanning for devices. But this repository we want to put onto our STM32 board. And the first thing that I do when I'm looking at a new board with Zephyr is go to the docs and look through as much as I can from the docs here. And I think that's how I figured out that you need a programmer. That's something I figured out last week. I was just going to try and run Blinky on this. And let's see what it says. Yep. So right here, the default programmer is STM32 Cube Prog. And that you can click through all these links and you get to where you can download the software here. And the nice thing is it does have a Linux version that operates on the command line, which is usually what I'm looking for. And so I got that. I was not able to run Blinky. I was talking to Chris about this earlier. I don't think that it has the magical LED 0 or whatever alias it is. So you could definitely alter it to run Blinky. But if you're just going to get it to run something, try the Hello World. I was able to get that running on here. And I thought, great, we're ready for the live stream. Except during lunch, Chris, I got nervous because I was like, I bet you have to download some binaries to make Bluetooth run. Because most of the Bluetooth devices that you use, like ESP32, or
actually all of them, I think
maybe all
even
of them,
like
yeah.
our gateway has also an HCI driver on it as well, in order to basically be a controller for the Bluetooth radio that's out there, all the stack, all the things like it. And then there's so like on our gateway firmware on that NRF 9160 or 9151, that is controlling the Bluetooth modem effectively through the HCI interface. And so it's doing the same thing. So and this is like the interface layer for a lot of different Bluetooth things.
Yeah. So usually you need to run like West blob fetch expressif or something like it's some West blob fetch command.
Yeah.
For whichever, I think what did I run it for? The Freedom board? What is that? NXP? I've had to run it for the NXP. Like it's just general thing. You're going to need some binary. And so I got Chris on the phone and he read the documentation. I guess I still haven't read the documentation.
Hey, you know what, Mike? There's a first time for everything.
Yeah. Right. So this is still on the board definition in Zephyr, and it says right here, to operate this, you need to have the coprocessor binaries, either the full stack or the HCI layer binary. And that ended up being kind of a rabbit hole. So it does send you over to this.
What just happened? Actually, no, we're just not going to show it here. So here is a QR code if you would like to watch how to install HCI on your device.
Yeah. So we're back to our Bluetooth private access, which is awesome. And if you go through all this stuff, it's going to talk to you about preparing a gateway. I have the gateway already prepared, so we're not going to do that. And eventually it's going to talk to you about building our application right here. So I've done this and I'm actually running on the NRF52840DK right here. And we can see that in our networks tab. Here's my 9160. Here's the currently running node. Here's a node that I connected a long time ago and I haven't turned on since. And we're going to add another node today. So basically, we just follow these instructions. And the first thing that we're going to do is create, it says a second device, but in this case, we're going to create a third device. So under my, this is the web console for Golioth at console.golioth.io. And I'm just going to go ahead and create a new device. And I'm going to call this one STM32WB5MM-DK. Is that right? What a mouthful. And auto-generated. Yeah, that sounds good. So we're going to add that. Done. And then we are, what was that?
You need the device ID now, I think.
Yeah, I need the device ID. I was just thinking about the order in which to do this. I'm actually going to copy this command first. So we'll tell you when you set this up, make sure you update your submodules. And then this initialization will set up the repository itself. And then this will fetch the dependencies. From the devices tab right here, I have my device selected and I can copy the device ID. Let's delete that out.
That's so you don't, the reason we're passing the deconfig on the build line is so we don't put it into the project.conf and put it into revision control, like I've of course already done 3 or 4 times personally.
Yeah, you could have several devices identifying themselves as one device, which is not going to be great.
Yeah, right.
And then this is STM32WB5MM DK, like that. All right, so there's our build command, and this is going to fail. And it's going to fail because it's looking for STM header files or like device tree files. And we don't have those because this repository was set up to not have them. So if I go in and look at the pouch repository, there's a manifest file called west.yaml in there, and it uses an allow list. So what that's saying is only get the things that are on this list. And so you could go to the Zephyr repository and look at what different HALs are available, but I just happen to know that it's HAL STM32. So I need to put that in there. And then I need to do a West update, but I'm going to do this one right here. That is the depth 1 because it won't try to download the entire internet. Yeah, you can see from this block, I did just grab the files I was looking for. So now I can run my command again. I don't technically need to do a pristine build, but I'd like to show off how fast my computer is since I upgraded the CPU and RAM. Look how fast that was. That was really fast. And then, so that was this command right here. And then the last one is just flashing it. And so, oops, West flash. We'll go ahead and do that. And the device is flashing. And
one thing that's interesting here too is the because it has a different runner setup, it's running with ST-Link. And that's one that I don't normally see. So it looked a lot different to my eyes where I'm used to like NRFJ-prog or similar.
Why you know work.
Yes.
There we go. Advertising started successfully. And then we should see the gateway query the device shortly. So the problem there was we didn't have the binary, the Bluetooth binary flashed on. I had erased it from my previous work to make this look like it was new. All right, so we did get an error reading a remote feature. But if we look at our networks, we will now see that we have 2 devices connected. One of them is the STM32 device, which let's see if we can get to it here. And we can look at stream data, and we can see it sent us a stream at 152, and my clock down here says 153. Success!
All right. Well, Mike, that was fast work to get that working. Should we try and shove in some sensor data now or no?
Yeah. So are there any sensors on the board?
I think there are actually. There is sensors. There's a temp. There's a ST temp one. But then I was looking at the starting. We can look at the board file for it.
Oh, there's the VL53LOX time of flight sensor on this.
Oh, we know that one.
That's crazy. We use that for our greenhouse demo.
Yeah.
And then,
what's the other one? ISM 30. Oh, 6-axis IMU. I'd say the VL is probably a good idea, if anything.
The VL, really?
I think so. It's in the. We can just go and copy the garbage can reference design. Editor Chris here once again, and what you're seeing is a fast motion of us doing everything. A lot of mistakes, and you can go and actually watch that entire live stream if you want to. But basically, we were not pulling in the right node name as a spoiler there. So yes, you can go and see us struggle and do that sort of thing. But once we do, well, you'll see here in a second.
All right.
Oh.
Haha! 6.6, is that right?
That is right.
66 millimeters. I don't think, maybe it was 66 millimeters.
You know the hard part about this, Mike?
What's
the
that?
metric system.
I was going to say device.
I mean, not only did Mike just enable an entirely new ecosystem onto the Golioth Bluetooth Cloud, which he did, he then enabled the sensor board to be sending. So now, ST, you now have your dev board sending to the cloud using Bluetooth. That's pretty cool, I gotta say. We're using a standard gateway as well. It's not like a super custom gateway or anything either. So
yeah, that's another pretty neat part of this is that the gateway doesn't care where, as long as you're speaking GAT, the gateway doesn't care
GAT and
what
pouch.
hardware you bring. Yes,
GAT and
yes,
pouch.
of course.
Yeah. So that's a wrap on the STM32WB5. We're going to continue to bring new boards, new vendors, and new chipsets into the Golioth ecosystem using our Bluetooth Cloud capabilities and our Bluetooth SDK. If you have any boards or chipsets you really like, please let us know over at forum.golioth.io. We'd love to hear you there. And if you want to take part, you can join our Bluetooth private beta. There will be a link down below. Until next time, thanks for watching.